Greetings, chemistry students. I had a request to do an example of me doing the very first problem on your assignment today. I thought I'd do a variation on it and walk you the process of working with the ideal gas law. You saw from your two Tyler DeWitt videos that it's a relationship of pressure and volume with amount in moles and temperature that we combined with a constant so that the products of pressure and volume equals the products of amount in moles times temperature. When we are doing these problems, we often work with the idea of standard temperature and pressure, STP, standard temperature, and that's 273 Kelvin or 0 degrees Celsius, and pressure, and that's 1 atmospheres, or well, any of the other standard units that you might see it in, but usually we just go straight to atmospheres. If you notice that the video gave you several different constants for R, and I made a screenshot and put that on there, but for this, if we're going to work in atmospheres, our gas constant R will be 0.0821 liter atmospheres per mole Kelvin. All right. How to do this first problem. Let's do a little interpretation first. We know that we're going to have our pressure, our volume, our amount in moles, and our temperature mentioned in the problem. And our pressure, well, it says at STP, that's 1 atmosphere, standard pressure. Our volume, well, that's what we are supposed to find. Our amount in moles, was given in grams. 135 grams of water vapor, but I need it to be in moles. So I need to get rid of grams and turn that into moles. How do I do that? Ta-da! I need to use molar mass. And I know that 1 mole weighs some number in grams. So if I look at the periodic table, oxygen weighs 16, hydrogen weighs 1. There's 2 of them. So I know that the molar mass of water is 18 grams per 1 mole. So I can multiply that. 135 times 1 divided by 18 is 7.5 moles of water vapor. So my amount was 7.5 moles. And my temperature, well, it said standard temperature, and that is 273 Kelvin. So there I've listed my variables. Now I have my relationship PV equals nRT, and I'm being asked to find V. So to isolate that, that would be the product of nRT divided by the pressure, and that would be set up as 7.5 moles times 0.082 liter atmospheres per mole Kelvin, and my temperature was 273 Kelvin divided by my pressure of 1 atmosphere, and then I punch all of that in my calculator, and that came out to be 167.895. That's what my calculator says, but I've got too many sig figs. I have 2 sig figs here for my moles. I have 2 sig figs, 3 sig figs, oh, and 1 significant figure for atmospheres. But that's not really true. STP is a definition, and that would be 1.0 to infinity, because that's a standard. This is actually 0.15, and there's some more decimals that you could look up because this is a defined, just like saying exactly 1.0 moles to infinity equals 18 point whatever, if I read my periodic table more precisely. So I'm not going to let these constants, these standards, change my sig figs. So it's looking like I limited myself here with my given value of 7.5 moles. So I would just round my answer to be 170 What's my unit? Well, let's go back and look. Atmospheres has canceled out. Moles has canceled out. Kelvin has canceled out. So I'm left with the unit for my answer. Oh, good, because it's in a volume. It better be in liters. But Miss Kelvin, I've already turned mine in, and I said it was 168 or 167.9. Okay. Don't sweat the sig figs. I just want to see you set up the problem, defining the variables, and get an appropriate answer by being able to do the algebra. So there you go, an example problem. I really wish you guys could talk back to me. I miss seeing you and interacting with you all. I thought you would like my pretty amaryllis right here that are blooming here at my house. I hope you're having a wonderful time. Post pet pictures or something. I really miss seeing and interacting with my students. Take care and good luck. Bye.